Welcome to the Orissa, Texas podcast. This podcast was recorded in May 2023. In this podcast, we interview Bryan Palus and Jason Harris from Rok Technologies. During this interview, we discuss Enterprise GIS and Kubernetes with a very nice historical overview of Enterprise GIS. We hope you enjoy. Welcome to the Orissa, Texas podcast. Today we're joined by Bryan Palus and Jason Harris from Rok Technologies. Bryan, do you want to go ahead and start off, or Jason, would you like to start off and tell us a little bit about yourself and a little bit about what you do at Rok Technologies?
Sure. I'll go ahead and go. I'm Bryan Palus. I'm our Chief Cloud Architect at Rok Technologies. I have a background in GIS, went to school for environmental science, both bachelor's and master's, and in both experiences, I did find myself kind of leaning towards the GIS and technological side of things, whether it be spatial analysis or imagery analysis, along with a background just growing up being experienced to a lot of technology, that in the end I found myself here at this role at Rok Technologies, where I've really found a balance between kind of configuring and managing and setting up these enterprise GIS systems and really being able to apply what I know, both as a GIS user and an administrator, to kind of design and implement some of the better ArcGIS Enterprises systems out there.
Great. Thank you. Jason?
Well, that's going to be tough to beat, Bryan. That was really good and thorough. Let's see. So I guess much like Bryan, I also went to school. I have a bachelor's in geography, and GIS was sort of really it definitely wasn't in its infancy. So I graduated college in 1994, if it's going to date me a little. But I think we learned GIS on IDRISI, which is a cell-based application way back when. I'm sure some people remember it. Anyway, I've actually been working at Rok Technologies for about 25 years now. I think just over 25 years. I started as employee number one, and been here ever since. So I guess a little bit about Rok Technologies is we have been an Esri business partner since 1997. So we've been a really long time business partner. And for the majority of our existence, we did work. It was almost purely application development, right? So we started with map objects, and then there was ArcIMS. That was the big one for a long time. And of course, now we're sitting at ArcGIS Enterprise, ArcGIS Server. So we're developing these applications for these different Esri-based internet mapping solutions. And when we got to it hit hard with ArcGIS Server. We would develop these applications and hand them off to people, and they would look at us and go, well, we can't really support this application because of ArcGIS Server. We don't have the time or the expertise to keep this application up and running all the time. And this was particularly true of clients that the app was for public access, right? The public was going to be hitting these applications, and the last thing that they wanted to do was be responsible for an app going down or something not working. So that's the last thing they want, is for the public to be, calling their phone line saying the application's down. So what happened is we, as a company, started hosting these ArcGIS Server map services. And next thing you know, we're managing a giant cluster of ArcGIS servers, joined to a similar site, joined to the same site. And from there, it was getting hard to manage just because of the pure size of this enterprise. Actually, sorry, it was ArcGIS Server back then, not Enterprise. That's when we started looking at different options, what we could do in the cloud, right? This is sort of in the infancy of AWS. So we were a real early adopter of moving our infrastructure over to the cloud. Mm-hmm. So then it became, all right, so all these people are coming to us to host these ArcGIS map services, why are they not managing it themselves, right? Okay, we know they don't want to hear from the public, but we hear our hardware is old, we can't support it. We don't have the right people in-house to actually manage this, right? So we kind of pivoted from from application development to purely managing other people's ArcGIS enterprise systems in cloud environments. It's been a natural fit for us and our skill sets. So we're completely out of the application development game now. So for about, I guess, 5 or 6 years, we have just 100% been first migrating people's on-premise systems into a cloud environment, and then the ongoing management of that system. So managing all the security, managing the hardware, the software patches. We do all the ArcGIS updates and basically sort of shepherd that service, that enterprise system and services along. So that's a little bit about me, and that's a little bit about Rok. Mm-hmm. What else can I tell you?
So I actually had a couple questions, or at least one question. So can you put a date on when sort of the whole enterprise, you mentioned moving over to AWS and things like that. Can you kind of put a date on when that really jumped off? It's pretty common now, right? So.
Yeah, so I think the very first foray that we made into the cloud, I'm trying to think, I have the article somewhere, I'll have to look it up, but it was in the late 2000s, so I want to say 2009 or something. Okay. And we had developed an application. It was one of the very first, ArcGIS server REST-based applications. Mm-hmm. And this client, this was actually, I think this was before you could even launch an EC2 instance, right? This was, I think S3 was one of the only, or the main service that AWS had, or close to it. So we developed this application, we handed it off, and they were running it on their own, in-house system. And we bring these maps up, and they would, it was a cached map service. So these tiles would start drawing, but they would kind of plop in real slow, one at a time, bing, bing, bing. It would take a little while for it to draw as it brought those tiles down. And by this point, everyone was used to Google Maps. When you pan over, it draws. You mm-hmm. pan over, it's there. It's almost there instantaneously. And that's what the tiled map service really was designed to do, right? It was designed to appear immediately and not have any server time to actually create that image and push it down. But the problem was, we looked at it, and this client just didn't have enough bandwidth for the amount of people that were hitting this service. I think this is also going to date it a little bit, but he had I think it was a T1 or something to that effect. And he just did not have enough bandwidth to push these tiles out fast enough. So that was our first sort of experimentation in cloud. We said, hey, can we pick up these tiles and put them on a cloud service like S3, where they've got plenty of bandwidth. It's very cheap to store stuff, and they have bandwidth like Amazon has bandwidth. That's a huge amount. So this is actually before ArcGIS Enterprise had the built-in capability to serve tiles from S3. This was long before that. We just changed a little JavaScript around, and next thing you know, the client opens it up, and the application's coming from his server, but the tiles are streaming in from a different service, straight from Amazon. And that was sort of, to me, it was pretty eye-opening and sort of revolutionary. And now we think about it, when you open up your ArcGIS Enterprise portal, you've got data coming from your server, from Esri's servers, their base map services, other joined entities, all services are coming in from everywhere, right? Mm-hmm. And that was something that really kind of struck me. Like, something's happening here. Like, we have a huge chance to grow.
Yeah, even thinking about you configuring that in that method is kind of mind blowing. Just because now, like you said, the way Portal is, can take in all sorts of types of data and serve it. It just makes it so easy. And I think, another big thing, especially from like the client perspective, would be that release of Portal made it a lot easier for for these smaller organizations to think about putting enterprise, to host their own enterprise and manage their GIS data themselves. And we were able to kind of stand up that back end and that monitoring and maintenance and support for them. So now with Enterprise and with Portal, these things that you previously described that are very complicated, setting up S3 buckets and making custom JavaScript sites, and I can imagine that the type of S3 interactions you're doing are definitely different than what they are now. That's a huge jump, the introduction to Portal and Enterprise too.
Yeah, for sure. I was trying to think when, Matt, like you were asking before, when did it really kick off? People really moving their systems to the cloud, really thinking about it. And I would say it really started heating up 2018. I remember that people were still primarily doing ArcGIS server only, and Portal was released, but not a lot of people had adopted it yet. So this is like 10.6.1 maybe. So then with 10.7.1, we started seeing it really kick up. And that's, I would say, probably 2018, 2019. That's when we really started seeing a huge uptick of moving folks from on-premise to the cloud. And while we still do that, we still migrate people all the time from on-premise to cloud. We see a lot of people just starting in cloud. They're not even considering, standing up their own infrastructure anymore, which of course I think is a really smart idea, right? But it's funny to see these trends. Everybody's, not everybody, but there's a lot of people are migrating their systems, but there's a really large amount of just brand new enterprise people going straight to the cloud, skipping an on-premise deployment of any kind.
So pretty recently then, 2018 is pretty recent for, like you said, to see sort of a major inflection point in the uptake of this. Now, you guys work with multiple industries. Can you, not pinpoint an exact company, but can you, do you have any insight onto industries that were perhaps more early adopters versus industries that are sort of lagging, or is it kind of a mixed bag?
So I guess when it first started, surprisingly, I think it would be the larger organizations that had probably already have some type of cloud presence. Much larger organizations like Fortune 500s or very large private industries, and some of them, the very early ones, were large state level organizations. The people that it's always been a little bit tough to get the idea across to are the smaller, local county and city type governments. I think that was a bit of a tough sell in the beginning because that's just completely different than anything they've ever done. That's their data. It sits next to them. It's, they're working on it all the time. It's supposed to be right next to them. That was just a really hard concept to kind of get around in the early days. Now, Bryan, you're setting up a lot of these systems. The county governments and the state and the local, cities, they're coming over in droves now. It's almost like the old IT guy or gal retired, and whoever took their place understands the value of cloud and not having to deal with that physical infrastructure.
Yeah, this is Uriza after all, right? So, I think that, even in the kind of previous iteration of the business, like Jason was describing, where we're hosting a lot of data for people and map services and building custom maps around it, that was really beneficial to the small state and locals. That really, they had their data, they held it in their possession, and worked with contractors to get that data out in purpose-built applications. And now, with the cloud and the way enterprise can be set up, it can almost be a relatively lightweight, application in the cloud that these teams, which generally can be kind of small, can really focus on I think one of the things we say is like, you focus on your GIS, your mapping, and we'll handle the IT stuff that, something like a county or a small city, really struggles with, especially from the GIS office, where, there can be, differences or a lack of understanding between like an IT department and a GIS department as to what's important data and what needs to be available to the public and things like that. And so ArcGIS Enterprise, and getting that application into these people's hands, unrestricted, it really helps, smaller teams grow. And that's definitely something that we've found with these state and locals and small and beyond that, small engineering firms and design firms and things like that as well.
Even really large design firms and engineering firms these days. It's funny because just like you were talking about with state and local, and now the adoption is here. It's like that. What are they? The frog in the slowly boiling pot of water, doesn't know it's being cooked alive. I feel like that's almost, it's a similar story about, ArcGIS Enterprise. So what ArcGIS Enterprise, or say ArcGIS in general, is very typically known as if you go back 20 years, it was a desktop application. And then we, primarily working on our ArcInfo or ArcGIS Desktop now. And we had a little bit of interaction with, an enterprise geodatabase with SDE or SQL or Oracle. And then next thing you know, we've got ArcGIS Server, right? So now that's desktop, a database, and a server component. ArcGIS Server in itself is not an easy application to necessarily know how to manage and configure, right? Then we throw in the web server component, and then we throw in public access, so managing security. Then we throw in a portal. Okay, things are starting to get complicated now. Then we throw in a data store. Okay, things are really getting complicated now. Lots of ports have to be opened. Lots of lots of security things we have to watch out for, intrusion detection and virus and all sorts of stuff. So it's like the frog, it was in the pot. It's slowly that these on-premise, GIS administrators were being tasked. They had to be web server admins. They needed to be security specialists. They needed to be experts in ArcGIS and experts in ArcGIS Enterprise, all these different components. And all of a sudden, this thing just got really, really complicated really, really quick. So that's how we kind of found our niche, right, is being able to manage these things properly and set up the security. But it's still, if you think about it, we can automate these things and we can monitor everything. But in the greater picture, we're still managing, at a bare minimum of a 5 server setup for a base enterprise system. Not to mention imagery server and all the other server roles. So some of these systems that we manage are, upwards of, 20, 30 plus, big, large instances. That's still a lot of individual operating systems and individual application components that we have to manage. And I think that's sort of what's happened over time, right? We went from very simple to very complex. And now there's lots of these, individual machines that we're having to manage. And then Kubernetes came along, right? And I think that was the big impetus. Well, Bryan, you can probably talk a little bit more intelligently about Kubernetes, but I'll just say that, it abstracts that operating system layer, right? So if we have ArcGIS Enterprise deployed on Kubernetes, there's still underlying hardware components that we need to watch, but less of an overhead from the operating system. That makes sense.
Okay.
Yeah. So with, like you're saying, with Enterprise came along and it has all these great features to it. And I really like to think about it as, a singular application, but in the end, underneath, it is at minimum, 4 or 5 servers. And when you start to work with some of the bigger clients, some clients that have, uptime requirements, SLAs need to be met, just horsepower that needs to be addressed. This application, which sometimes you can think of as a singular thing, ends up being many, many moving parts that all need to be managed in harmony. And so, there, it's more than just a single, well, in the end, you could think of it as like one or two endpoints. There's so many things running underneath that. Mm-hmm. And with Kubernetes, you still have all of those moving parts, but it has kind of been abstracted away from the servers into kind of just like the application and, generic horsepower or compute running underneath. So there is a different level of concern for how the underlying compute and operating system like runs, to the point where a ArcGIS administrator really would just need to think about the services that they're publishing and the resources that they're using and what pieces of the enterprise application are being utilized the most, and how to address the resources to those individual pieces, while not necessarily fully being concerned about, well, what's running underneath? Do I need to check out application security or patching and operating system stuff and access to those machines, where in the cloud you can kind of like really silo those machines that are essentially running the application, but are in the end, through containerization, detached from the actual application.
Okay, so we had a lot of really great background and sort of reasoning on why the enterprise system is important and things like that. So you mentioned the word Kubernetes, and that's an important part of your workflow. Can we step back a minute? Can we just sort of define Kubernetes and get a kind of a general description of what that is?
Yeah. So I guess, we kind of just jump right into Kubernetes from traditional enterprise. And so I'll try and not talk about GIS, but in general. So Kubernetes is a container orchestration platform for modern applications. So as Jason was talking about, with the traditional ArcGIS enterprise application, there's tons of servers underneath, and they all have different roles, and they're all doing different things, and they need to be configured in certain ways. With containerization, you can run each of those individual functions as microservices. So you build out your portal as a container. You build out certain features of ArcGIS server as a container. Your data stores, you publish map servers and map or web applications as individual containers. And from there, you can utilize Kubernetes to define the rules of how these individual services interact with each other. You can very much limit what things can talk to what, while you can also manage how much resources are directed to each individual service, and build in things like high availability, build in things like auto healing and like quick recovery. So it's a different way of looking at like application deployment. So instead of having servers purpose built for each individual role, Kubernetes itself will act as like the manager of a pool of servers and deploy these individual microservices for ArcGIS Enterprise or any other application, and have them run on top of it without the applications really needing to know about each other, because all of the configuration is handled at the Kubernetes level.
Okay, so it sounds like, and I'm sorry, I'm just trying to make sure I have this correct in my head, and I could be way off base here, but it sounds sort of like almost like a motherboard or something, like where you have your different components of your computer, and then it all goes to one sort of brain that sort of controls everything and gets things synchronized for what the end user needs. Is that somewhat correct?
Yeah, I have a good way to think about it. So as Bryan was saying, previously what we've been looking at is these individual servers. Like we build out a server for Portal. We build out a dedicated server for the data store and one for ArcGIS server, all these different pieces of the enterprise. And each one of them gets its own server, right? The Portal is on server A and the data store is on server B, right? What happens if data store is using up all its CPU? It can't go and talk to Portal and say, hey, can you lend me some of your CPU? Can I use some of that? It doesn't work that way. It's unfortunately. So instead, what Kubernetes does is it takes you just give it a pool of resources. Here's 16 CPUs I'm going to give you to run Enterprise. Here you go. And it sets these up in these individual containers and then pods. And so ArcGIS server, I guess everyone can imagine it's probably the component that, uses the most CPU overall, right? Because it's drawing maps all day. And so it has this pool of resources. And so then when requests are coming in, hot and heavy for an ArcGIS server map service, it can use the CPU that it needs without having to, ask its brother Portal on another server if it can borrow some of its CPU. So each one of these work together, but they can also work independently to consume the resources that it needs versus another piece of that enterprise that's maybe not using quite as much CPU at the time. And it just removes that extra layer of junk that you can say that Windows will give you, right? I mean, it takes a lot of horsepower just to run Windows itself. Think about if you removed that and you could use all that horsepower for your application, right? Think of it more of like as a bare metal experience.
Okay, interesting. So this is a pretty new technology. I'm sort of looking at the background on it here, and it came out in 2014. So how long have you guys been involved in utilizing Kubernetes, and how important is it to your product?
Well, I can tell you from our perspective, right? So Bryan can probably speak to a little bit more about the history of Kubernetes, but when, we're a cloud first company. That's, like I said, we live in the cloud. We all work remotely. We've got people all over the country, and we all work together remotely, but, so we're very well versed in the cloud universe. And it's when you're working in cloud, you're going to hear Kubernetes all the time. That's just one of those cloud things, right? It's a cloud native type of application. So then when we kind of, we're business partners with Esri, and when we kind of heard that, they were getting ready to start development on a Kubernetes product for ArcGIS Enterprise, we were, beating down their doors trying to get on the beta list, right? So that's, for us, that's when it really started kicking off, is when we would do more Kubernetes, because now it's being offered as a Kubernetes native application. So that's for us. What was that? I guess 10.9 or 10.9.1, Bryan? Is that when it really?
Yeah, I think it was released 10.9. So yeah, we definitely, our experience really handling Kubernetes on a day-to-day basis was with the release of that beta from ArcGIS. But, when you think of Kubernetes and just kind of the way that it functions is just similar to managing cloud-based resources in general from your cloud provider, whether it be AWS or Azure. And to go back on what you're saying about it being like the motherboard, I think that it is almost like a modern cloud operating system. So it acts as like a central location just like your cloud provider, that has a set of APIs that you can send requests to do certain things with a pool of servers, right? So even in a traditional cloud environment beyond Kubernetes, when you're setting up EC2 servers, your standard virtual machines, you're sending a request to the AWS API and you're saying, hey, I need 3 servers. Can you stand them up for me? And it sends the request back and said, yeah, we did that. And here's your servers. Here's the information. Same thing with Kubernetes, where you're saying, hey, I have this application that I've developed. I've packaged it up in a container. So a Docker container. I've made a list of commands that need to be run to build this application. And I need you to reserve compute power from a pool of servers that I have leased and run it. And you need to run it this way. And I need you to give it this security requirement. And I need you to give it this high availability requirement. So it really is that orchestrator, that operating system of operating systems almost on top of it.
Yeah, I guess maybe my motherboard analogy was off, but I'm just thinking of like, when you're on your machine, like you mentioned, you have your firewall on Windows, and then you can allot certain cores to a program or something like that, right? So I think what you said about it being more of an operating system is probably more what I was thinking about as opposed to the physical hardware, right? But yeah, that's really interesting. So you see this, or I guess let me say this: how widespread is the application of Kubernetes currently? And is this going to be, is this the future, or is it already the future?
So Kubernetes as a general platform, cloud platform, is huge and widely adopted across enterprises. And I'm not talking about ArcGIS Enterprise. I'm talking about just enterprise systems everywhere. Mm-hmm. It's very mature. It's got wide adoption, and I think that is probably why Esri, put a huge amount of effort into containerizing and basically rewriting ArcGIS Enterprise for to be able to be containerized in Kubernetes.
So I think the natural progression of modern applications is towards containerization and Kubernetes. So yeah, I mean, Kubernetes developed by Google, everything running underneath Google Maps and Google services is all Kubernetes. And, again, it's very similar to just a cloud-based operating system. All of these cloud providers run like a similar framework. I can't necessarily say they're running a certain version of Kubernetes or they're running Kubernetes at all, but it's a very similar concept of application management and deployment. So, if the world is moving towards cloud, which we think it is, and, I think it's almost undeniable that a lot of the benefits you see from cloud are, being able to just have something out there in the web without having a team of people managing servers in a room somewhere or calling up a colo and setting up your own servers and managing all of that. It's just it's the way that modern web applications need to be developed. And, as we realize that, and, I think that enterprise in itself is really something that can benefit from that type of application pattern. And so they've realized it. And like Jason said, it's really impressive what they were able to do. They rewrote everything. It's not just, hey, we took 3 pieces of enterprise and containered them, because that's essentially what it is when you're standing up VMs and installing the 3 pieces of enterprise on them. Is here's 3 VMs that together, create enterprise. Instead, we've taken every single piece of every single function, broken it down into APIs and microservices, and developed their own containers for each of those, and web front end to manage those, which is big, because managing, containers and Kubernetes resources is pretty complex, and you don't necessarily want to be, as an end user, messing around in the command line or the cloud console, trying to figure out what's going on with your containers. And what Esri was able to do is make the management of the resources behind these individual services easier and capable of a web front end for managing those things. So, if you need if you need to address a certain resource need for a certain function of enterprise, you can do that through Esri's application. You don't need to go in the back end. You don't need to call up, your IT guy and say, spin up another server. I need to do this. You can point and click and say, hey, I need X more resources to go towards this map service that is powering our critical application, whether it be, your asset management thing for a state or local government or imagery services or anything like that.
A good example, Brian, we always talk about this internally because we laugh. Whenever it's hurricane season, we start getting a little nervous around here at Rok because we've got a lot of customers that are, along the Gulf Coast, along the East Coast. So we're always very cognizant of when it's hurricane season because that's when, someone will publish their hurricane evacuation map, right? So next thing you know, we're watching, and that server. This happened, several years ago. Thank goodness we were in the cloud already, but these guys were in the cloud. So we're watching these, and just the amount of requests were just coming in. It was overwhelming the server. So lucky for us, we did have the ability to spin up additional servers, right, and give it more resources. But that takes time, adding more, additional servers and making sure ArcGIS Enterprise is set up and they're sharing and it's highly available and, round robin. We were, able to keep the map service up, but I can imagine if this was already in Kubernetes, let's just add some more resources to this map service that's getting hit by the public so it can keep up. It's just a, very, very fine-grained control over all these different little aspects of your enterprise, right? So assign the resources where they're needed or intelligently distribute those resources where they're needed without you having to worry about it. I guess that's really one of the huge advantages of running ArcGIS Enterprise on Kubernetes is that it's, very, very fine-grained control over the different types of resources. And Brian, you could go on and on about this, about there's some architectural things that have been built into Kubernetes to make it a little bit more highly available and more fault tolerant, right?
Yes. So, that is, especially when you talk about people with critical services, whether it be emergency services or things that power, very popular web applications or, anything like that. I think a non-GIS example would be like financial tech and things like that, is having that service always be available, no downtime. And one of the things that you can do with Kubernetes and containerization easier than you can with traditional servers is set up failovers and redundancies in these applications. And that is a critical feature that we see in ArcGIS Enterprise for Kubernetes is being able to scale out those critical services, whether it be a hurricane evacuation map like Jason was talking about, or, just a large city or state's parcel map or some sort of business critical application that is running on top of that. Those things can't go down. And if they do, you need to be able to fix it quickly. So, if you are able to configure it to heal itself, then there's less response needed, less, less engineers need to run towards their computers when
like manual intervention, right? We don't want to have to intervene in this stuff and work. We just want it to work.
Yeah, and so, that's really important. I think you guys are really hitting some great points there, right? Instead of having, like you mentioned, somebody manually, keeping track of these things and looking at the resource usage, if you have something there that's kind of automated, right? You maintain your reliability, and that's really important for public safety and things like all the examples you're giving. I mean, the data is no good, the information is no good if it can't be conveyed to the people that need it, right? So this is sounds like a really wonderful technology that helps to maintain the reliability of these resources, right?
Yeah, that's absolutely right. You can think about it like, I remember Bryan earlier was talking about, Enterprise we think of as this one application, right? And, there's portal and server and there's data store. All of these things are working behind the scenes to provide that single experience of Enterprise, right? But if you think about it, what happens if one of those components fails? Let's just, argument's sake, let's just say it's data store. Data store goes down. Next thing you know, that means our hosted features aren't working. There's certain things in portal that are going to stop working. But if you don't know the data store is down, or if you need to spend the time to try to track down, it is data store. How did did you check? You probably checked a dozen different things before you check data store, mm-hmm. Right? So that's where these the automatic redundancies and it's basically there's built-in stability and high availability within Kubernetes, right? So Bryan, talk about how these things can heal and how they can determine that they're actually broken and spin up new instances.
Would it be helpful to kind of do a brief overview of what Enterprise is as far as the functions of it? And I know we keep talking about portal, server, data store, but is that something that you think
absolutely. I mean, anything that will help draw the greater picture here, I think would be good information.
So like Jason was saying about the individual functions, they do work in harmony to produce a single application, but they are separate. Like Jason was talking about with server, that's kind of like the original, server-based GIS feature where you can make HTTP calls to REST endpoints and they will return things to you, whether they be polygons or points, the data that you make a request to them and they return the data to you. I think Portal kind of gives you that web interface to make better maps with that data that comes with ArcGIS Server. So ArcGIS Online is something that's been around for about more so than Portal, I believe, and it's very feature similar, where you can create maps with kind of a better web interface than just playing around with whatever comes out of your ArcGIS Server endpoints. And with Portal, as opposed to ArcGIS Online, you get to own your data. You get to manage your own data, and that would then pull from ArcGIS Server. And then Data Store is kind of the in-house data management and data hosting platform. So, traditionally on-prem and cloud, cloud-based data management is done with SQL or SDE enterprise databases, and those still are very valuable. But with Portal, Server, and Data Store, the Data Store can act as kind of like a quicker responding place for critical data. I don't necessarily think you'd want to store your entire enterprise's data in Data Store, but when you publish a web service, you can put it in essentially closer to the application, make less requests to your on-prem or separated database. So that in itself kind of completes the application. So you have Portal as like your web front end. You have your ArcGIS server, which does the work, making the requests and returning the data. And then you have the data store that stores the data, right? Mm-hmm. So with Kubernetes, those functions still exist, but they're broken down even further. And so, like you're saying, if I have, all right, so I have the application, the Portal front end, and I have a bunch of employees. They're working on it. They are all doing web mapping and editing of data, and someone does something that whether it be accidental or on purpose, does something that takes a lot of resources. Whether I'm going to start hitting this service really hard, and God forbid the service doesn't have enough resources available, and something crashes or something becomes unresponsive to the rest of the team. One of the things that's built in with Kubernetes is health checks for each of these individual services. So if the system says that a certain map service is not responding in an appropriate time, and you have it configured to scale out, it will essentially just spin up a mirror of that service and then redirect all new incoming traffic to that new service while kind of retiring that older service and letting it maybe handle its current requests, but everything new will go to the new service that's put up there. So essentially self-healing. So, okay, we've hit this service hard, we broke it, but guess what? It's smart enough to figure out that, more requests are coming in, and so we will make available another endpoint for that request. Same thing with data store. It's a little different, just the data store having actual static data on it that needs to be preserved. But essentially what you would do is you have a primary data store and a failover data store. And in more complex situations, you can have a third one. And same thing. Hey, some person has asked for a dump of every single parcel in the entire state of Texas for some reason. And that's going to start, so not only is that request going through the server and probably hitting that service really hard, but then the data store itself is going to have to start thinking about, well, where are all these services, and pulling them up and exporting them out to the server and stuff. So again, the system itself can identify that there's an issue on this data store, and since we have a clone of the data store, sitting next door, the traffic itself will redirect to that backup data store, that secondary data store, the failover. And these are all kind of, most of these things could be classified as high availability, which is, very critical. I wouldn't call it a buzzword. It is definitely a thing that is very important to very many organizations, that these things don't go down. So essentially throughout the enterprise, this high availability is built into each of these individual functions. And that's a big benefit of Kubernetes over a traditional enterprise deployment, in that while it's possible to set that up in a traditional server-based environment, it's actually much more complicated compared to Kubernetes, where Esri has built it into the configuration of the application itself.
Very interesting. Okay, I have learned a tremendous amount today, guys. I just want to say that I really like your comments on most of the listeners to this podcast are probably going to be more on the analyst side, right? So the commentary about, having, companies like yourself and all the technologies that are surrounding it that are really helping to get the analysts' time back, to actually do their job and create value from the data instead of having to learn how to do all these different roles, like you mentioned earlier, I think that's really important because most folks who get into GIS and stuff like that, they want to work with the data. They want to bring value and find interesting patterns and do all that, that helps their organization, right? So having this technology and having organizations like yourself out there that can help to set that up and sort of take that load off their shoulders, it's really important. And then it's the Kubernetes and all the, as you mentioned, the redundancies and the safety features in there and stuff is fascinating because, again, if you can't access the information, then what good is it?
That's all. That was a really good summation, Matt. Good job. Yeah, that's all, very true. It's, the whole system as a whole is, very complex, and, moving to a cloud native architecture like Kubernetes is definitely, I think, the wave of the future. We all have to sort of get our people up to speed on how to work with Kubernetes. It's, as Bryan can attest to, it's completely different than dealing with a Windows or even a Linux operating system. It's just a different mindset, and people are going to get there eventually. It's just a matter of, how long that takes, who are the first adopters, and how it starts off from there.
Yeah. Well, and, discussions like we're having right now is really important to help people, better understand, right? Because people are naturally sort of, a little bit wary of the unknown, right? So when you say enterprise and cloud, it's this big scary thing out there, right? So when you can kind of break it down and explain what's happening, that's great to ease people's minds on what's going on, right? So
yeah, I think you, like you said, you just nailed it as far as, one of the things that we really kind of take pride in is letting GIS people do GIS work. And whether it's, Kubernetes or not, cloud-based, deploying the enterprise in the cloud and having a managed service team take care of a lot of that really opens up the availability of smaller departments or larger ones, but GIS focused departments to really just do the GIS and let people like us take care of like a lot of the complicated back end. So organizations could take inventory of how they're operating now and what their workflows are, and on it a lot of the time, while it does seem scarier and more of the unknown, like when you move to the cloud and move to enterprise and start fully utilizing things like Portal, if you're comfortable with ArcGIS Online, it really can actually start to streamline some workflows and allows the GIS department to do GIS.
Right. Yeah, that's great. All right, guys, thanks a lot.
Great to be here. Thanks for having us. It was cool.
Super.
Yeah, thank you very much.
Super.
This concludes the interview. I hope that you enjoyed the podcast and found it as informative as I did. Thank you.